Hi everyone, I'm Math Noah. In this video, we discuss a question asked by my AS level mathematics students. The question says, given fx equals x squared minus 2x minus 3, if the domain is x is between minus a and a, and the range is y is between minus 4 and 5, find a. Before we work out the value of a, it's natural for us to think about what value of x will give minus 4 as the function output, and what value of x will give 5 as the function output. Let's answer these two questions first. When the function output is minus 4, we have the equation. To solve a quadratic equation, it is often a good technique to make the right of the equation 0. To do it, we add 4 to both sides. The left can be factorized as x minus 1 times x minus 1, and the equation becomes. We know that when two numbers multiply to each other and the result is 0, either of the two numbers has to be 0. When this pair of brackets is 0, x has to be 1. However, this pair of brackets is just the same as this pair of brackets. X equals 1 will appear twice. This means that 1 is a double root of the equation. This will only happen at the vertex of the quadratic graph y equals x squared minus 2x minus 3. Also notice that x equals 1 satisfies this equation and this equation and this equation. This means that when the function input is 1, the function output is minus 4. This answers the first question. When x equals 1, the function output is minus 4, and this happens at the vertex of the quadratic graph. Now let's investigate at what value of x will we have the function output as 5. To do it, we set the function value as 5. To solve a quadratic equation, it is often a good technique to set the right of the equation 0. To do it, we minus 5 from both sides, and the equation becomes. Let's first factorize the left of the equation. It is a quadratic. Personally, I call this type of quadratics as simple quadratic because the coefficient of the x squared term is 1. This type of quadratics is very easy to factorize. The left of the equation is factorized as. It is very easy to check if the quadratic is correctly factorized as x plus 2 times x minus 4. X times x, we have x squared. Plus 2 times minus 4, we have minus 8. 2 times x, we have 2x. Minus 4 times x, we have minus 4x. 2x and minus 4x come together, we have minus 2x. This means that the quadratic is correctly factorized as x plus 2 times x minus 4. When two numbers multiplying to each other give 0, one of them has to be 0. When this pair of brackets is 0, x has to be minus 2. When this pair of brackets is 0, x has to be 4. Minus 2 and 4 are the roots of the equation x squared minus 2x minus 3 equals 5. We have answered the second question. There are two possibilities. When x equals minus 2, the function output is 5. Or when x equals 4, the function output is also 5. Actually, an input of a function and the corresponding output coming together form a pair of coordinates. and the pair of coordinates represents a point of the graph on the xy plane. Let's review what we have done. When x equals -2, the function output is 5. -2 and 5 form a point of the graph. When x equals 1, the function output is -4. 1 and -4 form another point of the graph. It is the vertex of the quadratic graph. When x equals 4, the function output is 5. 4 and 5 form another point of the graph. With these 3 points, let's sketch the quadratic graph. This is the quadratic graph. This point is here. This point is here. And the vertex is here. The graph is infinitely long. We just discussed the part starting from this point to this point. Let's focus on this part of the graph. The y-values of all the points lying on this part of the graph are between -4 and 5. Therefore, the range of this part of the graph is given by y is larger than or equal to -4 and smaller than or equal to 5. And it is the same as this range. To keep this range, the longest possible part of the graph to discuss has to start from this point, -2, 5, and ends at this point, 4, 5. If it exceeds this point, we will have a longer range than this one. When this part of the graph to discuss attains its maximum value, we will have the longest possible domain. X is between -2 and 4. Therefore, to keep this range, the longest possible domain is To keep this range, the shortest possible part of the graph to discuss has to start from this point, -2, 5, and ends at this point, 1, -4. If the part of the graph becomes shorter, we will have a shorter range than this one. When the part of the graph to discuss attains its shortest value, we will have the shortest domain. X is between -2 and 1. Therefore, to keep this range, the shortest possible domain is Notice that we have to work out a domain which is in this form, and the domain is shorter than or equal to this domain, and it is also larger than or equal to this domain. It is not difficult for us to observe that the domain is X is between -2 and 2. This domain is shorter than this domain, and it is longer than this domain. Therefore, the value of A is 2. Let us analyze the problem from another perspective. Let the part of the graph to discuss start from this point, 4, 5. To keep this range, the longest possible part of the graph has to start from this point, 4, 5, and end at this point, -2, 5. If it exceeds this point, we will have a longer range than this one. Therefore, to keep this range, the longest possible domain is X is between 4 and -2, and it is the same as this one. However, The shortest possible domain is x is between 4 and 1. Now, we have to construct a domain which is in this form. And the domain is shorter than or equal to this domain, but it is longer than or equal to this domain. Is it possible? Let's try this one. Notice that this domain is longer than this one. However, it is not shorter than this one. Actually, we cannot work it out. We know that from this perspective, we cannot work out any values of A. Let's go back to our previous discussion. In our previous discussion, the part of the graph starts at this point, and the longest possible domain is x is between -2 and 4, and the shortest domain is x is between -2 and 1. And it is possible for us to construct a domain in this form, which is longer than or equal to this domain, but it is shorter than or equal to this domain. It is x is between -2 and 2. Notice that this is longer than this, but shorter than this. Therefore, A is 2. And we have solved the problem.